Hello everyone, my name is Amit Yadav and I am from Rajasthan. I did my BSc from University of Delhi and now I am pursuing my MSc from IIT Hyderabad. So recently I have qualified CSIR NET exam with the rank of 63. Now coming to my topic, which is neighboring group participation. So we all have heard about SN1, SN2 and SNI reaction. These are the substitution reaction. So NGP is also a type of substitution reaction in which neighboring element participate in the reaction to give the product. So here the reactivity will be very different. So how it will participate? Generally we will see, just have an idea, then we will discuss some examples. So a very simple example I have taken. So here this is a normal SN2 reaction. We will think if we will add any nucleophile, but it is not normal. There will be the change in the rate of reaction. So this is alpha carbon, this is beta carbon. So from leaving group at beta position there is a sulfur atom which can act as a neighboring element or neighboring group that can participate in the reaction. So this is a NGP. So coming to the NGP, this we will discuss later. Before that we have to see some important points on the NGP. The first very important point is unexpected increase in rate of reaction. So there will be very high rate of reaction as compared to the normal SN2 reaction, because in NGP there will be formation of a cyclic transition state due to there will be unexpected increase in the rate of reaction. That also we will see in detail. Coming to the second very important point, which is the position of the neighboring element. It could be minimum at beta, also it can at gamma, delta, far away from leaving group. So these positions we have to see from the leaving group with respect to the leaving group. So minimum the element should be at the beta position, it can also at gamma, delta, and the intermediate of the reaction, intermediate will be cyclic. It can be 3-membered, 4-membered, 5-membered, 6-membered. So this reaction goes through a cyclic intermediate which is 3, 4, 5, 6-membered ring. So the smaller the ring, greater will be the rate of reaction, because when the ring will be small there will be high there will be high strain in the molecule and it will try to open as fast as possible. Coming to the fourth very important point, which is retention of configuration. So in normal SN2 reaction there will be inversion of configuration, while in case of NGP there will be retention of configuration. Now let's discuss these points in detail. So first we will see the increase of the rate of reaction. Why the rate of reaction in the NGP type of reaction very high? So two basic examples I have taken, from that you can get a better idea. One, a normal SN2 reaction, we have added aqueous KOH and we are heating it. So there will be normal SN2 product will form this one. In the second case we have taken an example where one CH2 I have replaced by sulfur atom. So in that case again I have added aqueous KOH and I have heated this reaction, then the product will be same as that of SN2 reaction. But one thing very interesting about this reaction is the rate of this reaction is 600 times greater than the initial normal SN2 reaction. Why this is so? So this we can see from its mechanism. So this is the neighboring element, this is the carbon Cl bond that is going to substitute by the OH minus. So at beta position, alpha beta, there is a sulfur atom which can act as a neighboring group, or which can attack at this carbon to form a cyclic transition state. So we can say it is a neighboring element which is participating in our reaction. So this will attack here because it is partial positive, partial negative, because of the electronegativity of chlorine is higher than the carbon. So it will form a cyclic transition state like this one, where sulfur have a positive charge. So this not transition state, we can say it is an intermediate. So this intermediate is unstable because of cyclic. It is cyclic. Also, the ring strain is very high because of a three-membered ring which have a 60-degree bond angle. Also, we can see because of the banana bond, it extended to the 102. That we will see in the different video. Now, nucleophile can attack from two positions. So this is our ring formed sulfur. Now OH minus, KOH we have used. So it can attack from both the position, from here also, from here also. So both are symmetrical, both are CH2 CH2. So there is no case of steric hindrance, like we cannot choose any one, so it will attack from any position. So product will be the same. So we will end up with the product, this one. So in that case, rate of reaction is very high. We can say only because of this cyclic intermediate, three-membered intermediate. Because of that, the strain in the molecule is very high and it will try to open as fast as possible. Because of that, this reaction is very fast. Now, we will see another example which will make a very clear picture of the NGP. So this is this one. So NET2. It is a ethyl group. So there is a chlorine which is a leaving group. Also at beta position there is a lone pair of electron which can act as a neighboring group. So this neighboring group will participate here. It is partial positive, it is partial negative. So it will form aziridine molecule NET. So it have a positive charge. Okay. Now there are two possibilities. Nucleophile can attack here also, nucleophile can attack here also. But it also depends on the type of a nucleophile. If we are adding H2O, so H2O, as we know, it is a weak nucleophile. So weak nucleophiles generally attack from more hindered position. Why this is so? Because it is a weak nucleophile, and from that pathway it will follow SN1. Because it is a weak nucleophile, it will not directly attack. First it will wait when the ring will open. So first in this case ring will open. So it will definitely open from the position where the carbocation will form more stable. So it will be like this. The carbocation is formed here. This carbocation is more stable than this carbocation. So here we have only one hyperconjugating hydrogen. Here we have 3 hyperconjugation from this side and 2 hyperconjugations are from this side. So minimum 5 hydrogen which are showing hyperconjugation and stabilizing this carbocation. So in that case water will attack from this side. So this is the mechanism for this reaction. Et2. So it will OH. So this is when water will attack. While in another case when hydroxide will attack, because NaOH when we have added, it is a strong base. So strong base will not wait until the ring will open. So definitely it will attack from the less hindered phase. Because in SN2 the rate depends on both substrate and the nucleophile. So here it will form OH. So this will be the major product. So it is a very interesting question. Here with water we will end up with getting this product. So in the first case there is a participation of a neighboring group. In the second step we have seen attack with the sodium hydroxide, also attack with the water. With sodium hydroxide it will follow SN2 type mechanism, while with the water it will follow SN1 type mechanism. So this is so. Now coming to the next, a very important example of the neighboring group participation is the configuration. Third point we have discussed is retention of configuration. So I have 2 examples. Just we will see fastly. OTS, tosylate, Another example is OTS. So in that case, when we will add nucleophile. So here is a carbon from at which there is a leaving group attached, OTS. So this is a nucleophile. So in that case, there is not any group present in this molecule to behave as a neighboring group, so that it will go via a simple SN2 reaction. So there will be, in case of SN2, as we know, group will attack from the back side and inversion of configuration will occur. So group will come here. So in that case, there is a inversion of configuration. While in coming to the second example, there is a presence of a double bond which can act as a neighboring group participating element. So, or we can say neighboring group participation electron density. So it will go there, attack here or at this center, and it will leave OTS. Now here the intermediate form, very interesting, is 3-membered cyclic transition state. Okay, so here is also, there are two possibilities to attack the nucleophile. One can attack from this side, another can attack from this side. But from this side, there is a double bond. As we have seen, this is shifted from this side. So because of this it is not double bond, it is a single bond formed by the rearrangement. So this bond will give hindrance to the nucleophile. So nucleophile will not approach anyway from this phase. Definitely in this phase there is a no steric hindrance, so it will attack from this phase to give the product. So the product will be like that. It is nucleophile. So in that case there is a retention of configuration. So in the normal SN2 there is an inversion of configuration, while in case of the reaction in which neighboring group is participating, there is a retention of configuration. Now I have one more example, which is a very important example. We can say the participation of a benzene ring, phenyl ring in the neighboring group. So I have taken a very simple example, CH2Cl. So in this reaction there is presence of a double bond adjacent to the leaving group, alpha beta we can say. So here at beta gamma carbon have one double bond which can act as a neighboring group. But in that case, many times students confused because it is a benzene ring. So benzene is a highly stable molecule in itself because of the resonance, but still there will be neighboring group participation, and because of that we will end up in getting with a very high rate of reaction. So this will attack here and the Cl minus will come out and it will form this intermediate. So initially it was aromatic, now it have lose its aromaticity. So definitely it want to get its aromaticity back. So the nucleophile when come, it will attack very fastly to get the product because of the stability of the product. Because product will be aromatic. Let's see how it is. So there is also two possibilities, one from this side, another from this side, and both are symmetrical. So there is no difference. So we will attack from any side we can attack. So I have attacked it from this side, so it will open up. It will go as a double bond. So here a nucleophile is attacked. So this is the reaction which have a neighboring group participation of a phenyl ring to give the product which have a very high rate of reaction. So this is I have tried to give a basic idea of neighboring group participation. Thank you.